2x plus 3 and x minus 1 are factors of this quartic. Find the constants a and b and then all the zeros of the polynomial. So first of all, what does this mean? If these two are factors, it means that 2x to the 4 plus ax cubed minus 3x squared plus bx plus 3 is equal to 2x plus 3 times by x minus 1 times by some other factor. Given that when we multiply these two, we're going to get a quadratic, and this is a quartic, this one is going to have to be a quadratic as well. Let's call it like that. Now, I can't use a and b because I've already used a and b here, so let's call this m and this one n instead. Now, I'm going to equate coefficients to find these missing values, but to do that, first of all, I'm going to expand these two. You get 2x squared plus 3x minus 2x is plus x, and then minus 3, and then times by mx squared plus nx plus c. Now immediately I can work out two of these, because the only way I can get 2x to the power of 4 is the 2x squared times the mx squared, which means m has to be 1. And similarly, the only way I can get to 3 is the minus 3 times c. And minus 3 times something has to be equal to plus 3, so that's going to have to be minus 1. Once I've got those two, I've just got n to work out here, and then I can use that to find a and b. Now, to do the rest of this, I could sort of think about this and go through all the different bits in my head, but I think realistically with this type of problem where there's lots of things going on, we're best going back to a grid method approach to see everything going on. So we've got 2x squared, x and minus 3, and x squared, nx and minus 1. That means I've got 2x to the 4, x cubed minus 3x squared, 2nx cubed, nx squared minus 3nx, and minus 2x squared minus x and 3. Now looking at that, I can immediately see I've got the 2x to the 4 and I've got the plus 3, which comes from those two values I already worked out. And now I'm going to look at how can I find n using the minus 3x squared, which is this diagonal along here. That means that minus 2 plus n minus 3 has to be equal to minus 3 by equating the coefficients of x squared. That means that n has to be equal to 2. And now I know that this is equal to 2. Let's fill that in there. This is equal to 2. Now I know that, I can work out a and b by equating some other coefficients. First of all, a is the coefficient of x cubed, so that's these two. So a is equal to 2n plus 1, which is equal to 5, by equating those coefficients of x cubed and equating the coefficients of x. I get b is equal to minus 1 minus 3n, which is equal to minus 1 minus 6, so minus 7. So b is equal to 7. So I found a and b now. That's the first part of the question, 5 and minus 7. Finally, it's asking me to find the zeros of the polynomial. And the zeros of the polynomial are when this would be equal to 0. To do that, I need to find the possible solutions. Now, I know that this whole thing is equal to 2x plus 3 times x minus 1 times x squared plus 2x minus 1. And I want to know when is that equal to 0. So a bit like the way we solve quadratics, this could be equal to 0 if 2x plus 3 is equal to 0. That would be if x is equal to minus 3 over 2. Similarly, it would be equal to 0 if x minus 1 is equal to 0, that is if x is equal to 1. And it would also be equal to 0 if x squared plus 2x minus 1 is equal to 0. This is a quadratic equation. It doesn't factorize, however, so we'd have to use the quadratic formula to solve this. And when we do that, we get x is equal to minus 1 plus or minus the square root of 2. So the zeros of this particular question are x equals minus 3 over 2, x equals 1, and x equals minus 1 plus or minus root 2.